My name is Matthias Laug. I am a lead developer for ThoughtWorks. Since 2 years now, I have been previously the CTO for Takeaway or affiliated in Germany with Lieferando.de for 7 years. And at some point I decided I can only sell that many pizzas, so I want to see more tech again. I want to see different things. That is why I joined ThoughtWorks. And a current project that I'm working on, we are heavily utilizing micro-frontends. So today's story will be completely about why microservices, first of all, because I think getting a bit of the understanding first why microservices in general leads us towards the answer why actually the next technology step of micro-frontends happen in the end. And last but not least, I'm showing you some hands-on micro-frontends approach as we do it currently in our project. It will be a high-level overview. You see a little bit of code. And if you want to dig deeper, I can really recommend after the coffee break to join the talk from Elisabeth Engel. She's going to dig deeper, probably also into the technologies around. I'm definitely going to be there. So first of all my microservice talks, and I have done some in the past, I'm always focusing to make sure that everybody understands a monolith is not a bad practice. Right? So you can build a good monolith, yet a microservice constrains you to do things that are optional in a monolith. And by optional, I mean you just forget to do them. You just don't know you need to do them. Talking about decoupling, talking about good isolation, talking about proper dependency injection, etc. Contracts between the different services. Just because it is one big bulb of code doesn't mean you can't write it in a good fashion. And microservices pay off way later. So we have, at the beginning, when we want to start with microservice, we have to do a lot of groundwork. We need to set up infrastructure, tooling, etc. We actually need to define an understanding on how we're going to cut all our services of the application of the product that we want to build. While in a monolith, you can start pretty quickly in piling up features, experimenting with what you want to actually have a feeling if your product is actually worth bringing out to the market. So if you're trying out a new thing, you're starting a startup, don't start with microservices right away. Do a good monolith and cut them out once you're actually making money. So as a conclusion, don't do microservices if you can't build a good monolith. That just as a preface. So when we're working in the beginning with a monolith, this is the usual path that we're walking through. So we have a code base where a team's been working on, we build it, we deploy it on a server, and we ship some functionality. This is great. This is easy. We're 2-3 people, we just started our company, and this all works out. This is obviously a very simplified version of the whole workflow. But this comes with certain drawbacks. You have one repository, not a big thing in the beginning. Yet, you can only ship everything or none. You change a code line, you need to ship it, you ship all the other code commits that everybody else was doing as well. I think that is why even Git and SVN, they heavily utilized branching functionalities, and also that they introduced this a way of branching in a proper way with feature branch, etc. So if you want to do trunk-based development, it's quite hard. It's getting quite hard on a monolith the longer you stay in this code base. And also the organizational output of teams, because at some point your company is growing and you put around teams around the application, around your code base. And you might run into the fallacy saying, all right, we're going to cut our IT department into technology. So we have a front-end team here, we have a back-end team here, and etc. So you're running completely against Conway's law to say, okay, if you define it this way, you're actually ending up with exactly this structure in your code. And you have a front-end team, you have a back-end team. Yeah, and everybody's dependent on each other. And why is that bad? There's a formula in which you can define how many communication patterns you might have in a team. And let's just imagine your team is growing to 50 developers. 50 developers means 50 times 49 divided by 2, 1,225 possible communication channels. And you can imagine by those sheer possibilities of communication channels, confusion is been guaranteed. You will have lots of collaboration, alignment meetings. You probably have only meetings because you need to align. Because nobody knows what the other is doing. Like coming up to that sentence, and 80% of my time I'm telling others what I'm doing in the other 20%. So a separation of work is necessary. And this is something that has been figured out very early already. Like the 70s, 80s for informatics was actually quite a good thing. In 1986 by Brooks, the so-called there's no silver bullet. There's no single development in either technology or management technique which by itself promises even one order of magnitude improvement within a decade in productivity and reliability and simplicity. This statement led him to the book of the Mythical Man Month, where there were lots of talks about companies like Netscape, which have grown and grown and grown over time, and at some point they couldn't ship features that fast anymore, and they ran out of business. The same issue Microsoft had, but they fixed it at some point. But what does that mean for us? There's a limit for the scalability of our teams. And as much as we want it, our teams will never scale linear. The management idea of putting more developers on a project will delay the project further. There's no chance that you can catch up time that you lost in the past by adding more developers, onboarding, etc. I think everybody is aware of this. So the only chance to achieve near linear scaling is the microservice approach that we've seen so far. So you create cross-functional teams. Those cross-functional teams bring all the stuff that you need to ship your product, to ship your functionality, a certain functionality of your product, and you organize them around capabilities. That is what I strongly believe in, that you should not define your teams around entities, like a customer service with that customer team, an order service with that order team, but rather thinking capabilities, the search team, the vehicle selection team, the restaurant listing team, etc., etc. So here comes to the question, the answer to the question, why microservices? It lets you do one thing and one thing well. It's smart endpoints and dumb pipes. The significant difference between service-oriented architecture and microservices. I believe this is the only difference. Lots of people did service-oriented architecture and said when the microservice buzz is coming, well, we're already doing it. But lots of people jumped on the train and sold very expensive enterprise buses, and those enterprises became our new monolith. So all the idea, all the communication between the services were happening on this pipe, and every logic was in there, and nobody could understand it at some point anymore. And last but not least, it's composition over extension. If I want to extend my functionality of my product, I add new services, or I try to compose different services before I even add a new one. And then this becomes this. And we're back to how we started. But now, instead of having one big monolith, we're having multiple services that do the same job. Let's not forget this. This is still the same product. But each of those teams are able to ship their product. They're part of the application. So the promise is everybody can work autonomously. Choose the technology that you like, that some people are very afraid of when we're doing microservices. Yeah, those people are doing Java, those people are doing Clojure, those people are doing Go. Usually doesn't happen, still people are afraid of it. And you can release as you please. So whenever I'm ready with my code, I'm going to ship it. Really? Because, and here we're coming a little bit into the conclusion, we have a front end. We don't ship REST APIs. Okay, some do. But most of the people don't ship REST APIs. It's not what the users are wanting. It's not what the users are using. If you're in the happy situation that you're shipping for developers to consume your services, great. But in 80%, just making up this number, of the time, you have to ship a UI. You have to ship a functionality, an interface for which your user is actually interacting with your application. And this still feels like a very big application. Sometimes it even lets bleed in business logic, etc., etc. So, and even though we split up all our teams beautifully, we end up with having one front-end team. or again, multiple people, pairs from the teams working on the single code base. Because in the end, we all want to ship the UI. And we end up again with all this collaboration. So work autonomously, yeah, until the boundaries of my service. But then I need to change the front end, and it's one code base again. Hello, who's like working on the front end? Yeah, 50 people again. Shit, doesn't work. Choose a technology suitable. Okay, luckily a lot of technology choices are happening in the back end. In the front end, we're just choosing for one framework, the new hot shit that is right out there. Yet, sometimes there is real good examples of choosing a different JavaScript framework, if I'm just talking about the JavaScript ecosystem, that brings me forward faster. I have a very lightweight UI, I'm never getting big, why should I go with React? I'm maybe getting with Vue.js. And seeing here, one tech stack, of course, it is the same code base. And release as you please as well. It doesn't work because I need to collaborate with all the people. I've mentioned this. So one release stream, one pipeline, and you barely can do this. So micro frontends is the next logical step. And this is what we want. We want to be able to ship the whole pipeline through the value stream and release one single fragment of our application, in the UI even. Like dependency injection in our front end. So it's not just owning our service, it is owning the whole value stream. Do one thing well, yes, but until the end of it. So, and here we're coming to the point what I call Conway's equilibrium. Like usually your application is in a move, your teams are in a move, and whenever things in your teams change, automatically the application changes. Here we have a real chance to keep teams stable, to keep teams as they are, and to continue with those teams until the functionality as a whole shows non-necessary for the business anymore, and then we can shut it completely down. But we don't need to change around saying, okay, now the front is a bit too big. Okay, we're separating into two big things, the backend front end, like the admin UI and the user UI. So, things to keep in mind. In the process of building this monolith, I believe domain-driven design is something that is very helpful. You need to understand how to cut your services and also how to cut your top layer. And at this point, it becomes more necessary to not only think in entities, but in capabilities, as I've mentioned before. Because in the UI, you barely only work with one single entity. You're not working with a customer only. You're working with an order, with a customer, making an order on a restaurant with those meals. It's a combination of the whole. And so you need to think in capabilities, because capabilities have a bigger likelihood to be completely isolated as a service. Furthermore, what we did and what we strongly believe in is you should do coupling by design. There will be always coupling. So you have the chance in the beginning to define where the coupling will be. And we defined that each of our fragments will be shipped with one backend, all together. So there's one front end for one backend for front end. And there we know we have couplings. And whenever someone else has a necessity to consume data from our service, we provide additional endpoints. We don't let this service use the endpoints that are been purposed for its own UI. Very important. This is obviously cannot be easily restricted, it's more a convention. And furthermore, in the end, one layer is necessary. There's one single layer where we need to compose everything together. And this one should be as thin as possible. There should be near to no changes over time. You build it in the beginning, it should serve your purpose of putting the pages together, and that's the end of the story. Only if you add new components, you might go to this layer and add your new component or rearranging them. But the layer should have no knowledge at all about any of the logic and all the implementation details that each of the components entail. Furthermore, don't share the code between those fragments. But I'm going deeper there in a second. So how do we do this? Luckily, it's already been introduced. Netscape went out of business, I guess. 1996, frame, set, and frame. Who would dare to build an application with frame sets? Raise your hands. Okay, bold move. Bold move. Okay, it's half of a joke. I honestly mean this. The idea behind it is exactly that. You have different fragments inside your application. The way that frame sets and frames are defined have their limitations, so it's not a good use to build good micro frontends. Navigating through the page, etc., is quite of a hard thing to do. So we rather not want to do this in this way. So let's show you a real-world example. This is the product that we're currently building with a big car manufacturer in Berlin. Can't tell names, sorry, please don't ask. In the end, it doesn't matter for our case. So we have multiple aspects here that we see already. So our first step, once we drawn out the way as we believe our UI would look in the first iteration to serve the purpose of getting out an order, ordering a car, we defined the context and said, all right, we have a search capability, we have a so-called configuration capability, a financing capability, adding together the discounts, or people in the car industry love the discounts. I'm going to tell you, I can't tell how much time I spent in this component. And last but not least, one of the most important ones, the order component. Two technical challenges we faced there. There are lots of, I'm going to sum them up in the end, but two main challenges we faced. UI integration in the browser. This thin layer I was talking about, how to put things together. How would this work? And the second is communication. There will be communication between your services, but how to do that? And how to ensure it's stable and it doesn't break when you deploy new features. Because if you have multiple teams running at different velocities throughout the stack, some teams might be slower, some teams might introduce things faster. You always need to be sure that they really can independently deploy. Because otherwise, someone is going to cut the cord and saying, no, we're going to do manual tests before every release with every service, and we define a matrix which services can only work together. And you don't want to come in that situation. So let's talk about the UI integration. You might at that point realize that this presentation is patchworked out of two. The style changes now. So the integration in the browser, we had three possibilities of which I'm going to talk to. We could do it during build time. We could do it inside the browser, so at the client side at runtime, or we could do it on the server side at runtime. I'm going to talk about the first two. So the first approach that we actually also did was we were using NPM. NPM as a dependency manager within the JavaScript ecosystem was enabling us to compose together out of different modules, out of different repositories, via Nexus, etc., everything into one, what we call frame.js. Frame, when you see it further on, is our name for what we believe is the thin layer. We called it frame. So all that's been put together had some pros and cons. First of all, NPM offers a reasonable dependency management. I'm saying reasonable because if you haven't updated it to a certain version, you don't have the locking mechanism or you're not using yarn. You have a non-deterministic dependency management. Means whenever you build your application, you might end up with different dependencies. It's a pain. And debugging this, that your version, you didn't deploy any new code, but actually your application all of a sudden behaves differently, is weird. You have one network call. This is definitely a pro. Everything has been squashed together and released out. It depends on what kind of application you want to build in the front end. This might be a non-functional requirement even for you. And independent development across teams has been ensured. Yet, you have a monolith in the end again. Your app.js in the end is a monolith, and you cannot do atomic deployments. What do I mean by that? I'm going to change my code of team A, but I don't only have to deploy team A code, I also need to deploy frame again. because Frame is going to compile everything together and release it out. So I always have 2 deployments, even though I only changed 1 code base. So it's non-atomic. Doesn't necessarily mean it is a bad thing, but it's, again, a hassle and additional time to get to production. The second one, and this is the one that we ended up with, is we did the integration during the runtime. So we again have our Frame.js, and Frame knows, and this is the only implementation detail that Frame knows about all the other servers. It knows just which servers are out there. So it's going to ask this service, it's going to ask this service, it's going to ask this service to give me your JS file and give me your CSS file. And I'm also all going to put them into tags, in JavaScript import tags and CSS import tags down at the body tag. That has its pros. We have independent teams again, so we can deploy atomically. We have no versioning issues. We don't need to care again about the versioning of application, increasing it always. Of course, we can automate that, but who wants to work with versions? We have multiple network calls now. Because, to give you an example, in the current scenario, we have 12 services. This means 12 calls to the services and 24 calls to JS and CSS files. This is a lot. This can be a lot. Since our application is to be run in a local network, we don't care about it. It's none of our functional requirements. And once those things are loaded, they are not been loaded again. And since it's an iPad application in the end as well, we shouldn't even care about reloading. Sharing data between the services. Our second big challenge. The possibilities that we have here is the React way. We're going to hand in properties. Sounds easy. So we look again at our overview. We have all those different capabilities, and they need to communicate with each other because they need to know in which frame of a deal they are. So which deal are we currently talking about? Have we placed an order already? Has a car been searched? Can I activate financing then? Because without a car selected, I cannot define the financing. So we need to group within our frame all those different sections, and we hand over properties. And at some point, this gets really messy. You add more and more properties, and at some point you're realizing that you're kind of working with a context that is floating around, but you never really defined it. And it is progressing very rapidly as you add new functionalities. So we dropped this one. So we thought about the Redux way. And all right, within Frame, we could put in one single store and use the capability within Redux that we can compose reducers into one single reducer again in Frame. So all that Frame does, it expects that every component is exporting a reducer. It's going to put all those reducers together, and then everybody can trigger actions, and everybody could listen again to those actions. Yeah. Worked in the beginning, but at some point we said, we're conflicting with certain actions, so let's rather namespace our actions now. And this moment where we namespace our action, we said, okay, why don't we just separate it in the end after God? So in the end, and this is the way that we decided for, it's a backend way, the old school way. So we let the backends talk to each other. And this has a very simple reason. It is boring. Boring is good. Boring means I can control it. I have an overview. I know what I'm doing. It is yet enforced by convention, but contract tests. I haven't seen yet a good tooling on the front-end side where I can ensure that the communication between my components in the JavaScript runtime is working to ensure contract test. Backend calls, HTTP is as old as it gets, and there we have good toolings, good ideas how we can ensure that whenever or before I'm deploying new things, I'm going to have an idea whether it works or not. So we can do consumer-driven contracts, and we can all do those fancy stuff that has happened over the past 4 to 5 years to get control over microservices and use it again. So whenever a component in our backend needs data from another context, from another bounded context, it's still going to call its backend, and the backend knows to go to the other backends. These contracts are being assured, data's coming back, and the component can work with it as it likes. So it's better to have a known devil than an unknown angel there. All right, let's see some code. This is actually real production code. And I'm guide you through. This is the starting point. This is one of our components. And the crucial part there is that we define our output of our Webpack configuration to be a universal model definition. So we're not generating an app.js which has an index file which has been loaded by the index file. No, we are generating a UMD. This UMD has one file, it's called component.js, this is the bottom one, in which we can define what we want to expose to the outside. What do we want to expose to frame, our thin composition layer? So we see we have here retailer reducer, so we have our reducer exposed. We have routes, and we have some sagas. So all this is the basic to make it available in frame. And then there's whole lots of implementation details around, but those are not been exposed. The internals stay internals. Following further, now we need to load the data. So this is the part where frame comes in place. Sorry, I was wrong here. This is still our component. We need to expose our app.js and our app CSS that we want to give to frame. So every of the application, this is closure. This is actually just for to show off. This is just looking into its own file system and looking for the app.js and the app CSS. You remember the point that we made the coupling of the front end and the back end? We even shipped them together in one Docker container. So we're going to build the app CSS and app.js. We're going to put it into the Docker container. It's the only two files from the front end, and there's a whole lot of backend then. And the backend knows in this folder, I can expose via an HTTP endpoint the URL to my app CSS and app.js. So we have a backend and a built front end in one container. That is how we are right now. The second, and this is copy-paste Stack Overflow. I'm not going to take credit for this one. It's loading the scripts. So you imagine in the background, as said, Frame has the idea which services it's going to load. It's going to iterate over those exposed HTTP endpoints. It's get URLs to the app CSS and app.js, and it's going to call this function. And all it does, it's going to add script tags to the bottom of the body. It's been loading those asynchronously. You see all the details down there. Each of those loaded components have a clear error boundary. So we use the React capability of setting error boundaries to making sure that what we're loading there is not breaking the rest of the application. Things can fail only by itself. And there it ends. And JavaScript is very fragile when it comes to errors. Specifically in the Internet Explorer, everything stops. So we're ending up having this. We have our backend, our built front end, and Frame.js is going to load this data into its context. And it does those with other services, and it continues and it continues. So you see, we can add new service, and the only thing we need to do in Frame is we need to add, we need to add another name. Just another name of the service. It automatically knows under which domain it is, because it is in one cluster together. It automatically knows where the URL is, because the URL is defined by convention. It's going to load the JS and the CSS, and it's fine. And this is then all that Frame does in the end. It's going to take its own header, footer. Yes, those things we keep in Frame. And then we have a lot of things that are externals. And we're going to load those externals in. And from this moment on, we have all the components in a certain composition on a certain page. We compose also the routes, so the components automatically react once they've been clicked to different URL changes, and it works very flawlessly. Wrapping it up with the other challenges that we faced. Assembling all fragments seamlessly was a tough job. Even though I said this was copy-paste from Stack Overflow, finding this piece of code, you need to know what to look for. So finding the idea how to put this in is quite hard. And then making sure that your implementation details are not bleeding into a frame. Very easily you're getting to the point saying, wait, we don't want to repeat yourself, right? Dry is one of our sacred grails. Let's put things like banners, pop-up boxes, etc. Let's put this all into frame. No, please don't. We have the worst issues with that. Because someone is changing the behavior of a pop-up box because they think it's more suitable for their behavior of their application, and all of a sudden it breaks user experience-wise for everybody else. So rather see it as an advantage, or build your code the way that it is copy and paste ready. Whenever you're scaling up your team, make sure every single component of your service where you're scaling up the team or adding new service is copy and paste ready, because people are going to copy and paste. They're not only going to Stack Overflow, they're going to write this test the same way as you have written the first test. They're going to write HTTP codes the way you did the HTTP code before. They're going to copy paste all over the place. Make sure it's ready, and then rather repeat yourself. Obviously, stable acceptance tests, they're already a pain in the ass. It's really hard to keep them stable. You need to put a lot of food of thought in there to make sure that Selenium or whatever you're using run through and actually gives you valid feedback and not just, let's just rerun it. And last but not least, slicing out the bounded context. It's definitely one of the top 3 to the 2 I've already mentioned, but it's a topic by itself. I could talk for hours about this one. It needs to be very clearly, you need to have a very clear idea on how you're going to separate your application. You need a very good understanding of the domain that you're working in. You need to have a very good understanding of domain-driven design in general. And you need to have people you can talk to, the domain experts. Fallacy of try already mentioned, error boundaries already mentioned. Error boundaries have been recently introduced in React. I'm not right sure how it is in other applications. A simple try-catch doesn't work. I can't give you the details now, but we figured out it just doesn't work, a simple try-catch. So, wrapping it up with the conclusion. We had microservices in the beginning. Microservices allowed us to build application in a different way to enable to keep developers at pace. And this is something that I like to stress out at the beginning every time. It's never been invented to increase the pace. It is to sustain the pace over time. So that no matter how big your company gets, the output of this very team that you already had in place stays the same. And it's not going to change. Thank you. Questions?
If you have questions, I'll be there with the microphone, so we get it on tape.
You said organizing teams around capabilities. Do you mean application capabilities or team capabilities? Can you please give an example?
Domain capabilities, product capabilities. So not just the capability of a database or a front end, etc., but actually something when you're talking to a non-technical person, what they believe the capability of the product should be. It should be able to search. Search is a capability. It should be able to list restaurants. Listing restaurants, finding restaurants in certain areas is a capability.
So you would create 2 teams for this? You would create 2 teams for this?
I would make one distinct choice, and this is, are those 2 things highly affiliated? Then it's likely that they may begin in a team together. If one of the capabilities outsizes in growth the team, then I would split it. But we would make the distinction of those 2 capabilities very clear in the beginning, that again, the service itself, talking about a monolith need to be built good as well, that the monolith that is wrapped around those 2 capabilities is built in a way that I can pull out this service easily.
Hello. You say, okay, each team is responsible for its own CSS, right? If I understand. How do you deal with the same look and feel standards? I mean, a user wants to have the same user experience, and if that look and feel is quite different for each frame, so yes, then you have to align, I think, as well there. Or how do you cope with that?
That is correct. So each team has their own CSS. We avoided to have any global CSS at all. We have a tiny one that is just for the margins. That's all our global CSS as it gets. You need to have alignment there, and it comes down to the point where I mentioned that instead of every developer needs to talk with each developer, you have only single communication channels between the teams. But yes, alignment of user experience and UI is a tough job, which as it usually is, you just need to be aware from the beginning. You can set up guilds, you can set up frequent meetings, you put an XD on top of the teams and saying, I'm going to be the like the champion of all this, and I'm going to check that everybody goes in the same direction. Yet, what we have seen is that a lot of times we generate more opportunity than actually drawbacks, because there are parts of the application where components become over-designed because they need to serve all components' purpose. For example, a select box. A select box becomes out of a sudden searchable with input fields, etc., and you can multi-click. While there's one component who only has a selection of 3 things. I don't care, yes, no. Why do I need to search this? So it results that every component that has been built has been rebuilt, so we're creating a lot of duplication there, yet it has been designed exactly for this purpose. So XD, like user experience, can differentiate between applications, but it is suited for the purpose of the user in this very moment.
Thank you.
I think that was questions.
Thank you. Hello. I'm wondering, how do you test the fragments on themselves? Because then you need to have a framework for every service, or yeah.
Good point. So we always have 2 modes. We call it standalone and dev. In dev, yes, we would need to spin up locally the Docker container of frame and then go via frame and check our component. Simultaneously, we also have a standalone mode. This means we are running the application and building it not as a UMD, but as a normal React application with an index HTML in the end. We're going to load this. The experience we made with this is, yes, it is very hard to make sure what you build comes the same way into frame, and you can actually rely on it. Yet, if you keep the teams isolated this way and rather make the pain than in the pipeline that the functional test is not working, people take a lot of effort to making sure that their standalone mode works. So our standalone application looks completely different to what it would look like when it's completely with frame. An example is that you've seen those tiles. No. There we go. Oh, that was too fast. There. You've seen those tiles. I'm actually working in the teams who is responsible for 3 of those tiles. When we start the standalone mode, those tiles are just top to bottom, black and white, underneath each other. Sorry, same color, but underneath each other. So they are completely differently arranged because we built our own index HTML, and we just need to make sure they're clickable. But it's the same way we import them in our index HTML as we import them in frame. So this needs to be assured. But yeah, it's exactly the issue. Contracts between front-end components, if somebody has an answer to that, how to do that, I'm happy to chat about that.
And do your capability-oriented teams have a leader?
So on ThoughtWorks, we have a certain idea how we're going to arrange our teams. There's always a tech lead, and there's always also a BA. And the BA is usually the one who's like the champion of what the capability of the team is and making sure that scope is always cut at the borders clearly.
Going back to this, question. Do you run your functional test in your build pipeline on the composed thing or on the standalone version?
On the composed thing, yes.
On everything?
It is a tough decision because we decided so far to have clear ideas where we need to do function tests and where we need to do integration and unit tests. So our approach currently is the functional tests are not cross-cutting concern. So we only stay in the boundaries of our very service. So example is, as I said, I'm working on this team with the search, financing, and order. We're selecting a car, we're setting some discounts, and we're going to try to place an order. We're not going to go into the other application, which would have an impact on us. For example, going to the retailer service, where you can define the transport cost that it needs for a car to go from A to B until you can buy it. We went through all the processes and made sure that there are unit tests and integration tests and contract tests to make sure that this is working. We decided not doing functional tests cross-cutting concern. So far, it went well. Okay. Up front is here also a question.
Sorry. You said in the beginning you don't want to share the in the frame.js share some properties of the services. How do the backends know which is the context of the user now? Are you using the user session?
We're using JWT, JSON Web Token. The thing is, with those kind of isolated teams, the responsibilities of those teams increase significantly. They are responsible for authorization out of the sudden. They are responsible for their own stack, etc., etc., etc. There's only one thing that we said, all right, this is too crucial. We're not going to put it into the teams. We're actually creating an own capability over which everybody in the real environment needs to go, an authentication service. But authorization is down to the components. The authentication service is just checking, is that user actually a valid user? But what that user is able to do, allowed to do, has been down to the components. It also belongs together that it is for one company, an internal tool, resulting in that authorization is not the worst thing that can happen if something goes wrong there, as long as the user is authenticated. We don't want anybody here in the room just go on the platform and buy their AMG, I know I said it, for €1. Shit. Please cut this out.
I'm going to follow up on the last question. You're saying that each component are actually resolving user information, for instance?
Just authorization infos.
Okay.
So inside the JWT token, there's just actually very encrypted lines of what kind of authorization, what kind of what the user is allowed to do. We don't even know what that user's name is. We just know that person is allowed to do that.
Okay.
So a question up front here.
Did you have a scenario where one fragment depends on another fragment to be hindered?
Yes.
And how is the communication between them?
There is a magic wrapper around those tiles. This service is called Deal Picker. This deal picker is responsible for creating the deals and managing the deals. So we hand over the tiles via frame to this component. The component yet doesn't know what this is. It just knows it gets a list of components which it iterates through and displays here. That's all this component knows. So we always try to keep it very, very clear and not even introduce that certain functionalities for the search service are then been happening by deal picker. Even though it might be then faster in the minute, we just don't do it. So this would be an example. We're handing over components to other components to display those.
Right. Is it in client side or?
Client side.
Client side, all right.
Yeah.
Great.
One additional question to this authorization. You said that in the token you write the information what the user is allowed to do. Is this a global thing or is this something each service is adding to the token?
It's a cookie, and since we are using same origin HTTP calls, this cookie has always been handed over to the other service.
And it's added by a central service which adds the information what the user is allowed to do over the whole application.
Yes, this is even a service that we don't own. So we actually doing kind of an open auth proprietary tool that we have to use. We're going to call this service. It gives us all the validations if the user is actually allowed to log in. Then we're getting over the JWT token encrypted to us. We validate it. And we pass it on to the other services. And again, their responsibility for validating the JWT and also extracting then the necessary information from it. And yes, we had so many talks that this token becomes the transporter of information. Yeah, as usual. We have a tendency to get global because we believe it saves us time. Or to, instead, we're repurposing certain certain capabilities within our services. So.
Thanks for the talk.
Thank you.
Just a question for clarification. So in your acceptance tests, you only focus on the scope of the functionality for a single capability. So you don't have any testing for a whole customer journey in your acceptance test, but instead, you rely on testing, passing state, and so on like integration tests, or
correct.
Okay.
Maybe one additional information to that. As said, this is 70% of the flow. This selecting a car, financing, order, etc. So we have one team which is kind of doing the main flow already, but there's lots of things around to enable to do that flow faster. So it might be due to that we haven't seen the need to actually build a whole thing that goes through all the use cases that are possible to do to enable a salesperson to sell a car faster. All right. And thank you very much for the questions.